3, we're going to look at an equivalent expression for the square root of 63 x to the 9th. Now notice that x to the 9th is under the square root sign. It's under the radical sign. So I know there was a Math Excel recently that was throwing people off with this very idea. So we need to look at how this works when we have a variable with an exponent under the radical. So we know that we can start by taking that square root of 63 x to the 9th, and we know that we can break it up into the square root of 63 times the square root of x to the 9th. On a previous example, we looked at the factors of 63 being 1 and 63 and 2 or 3 and 21 and 7 and 9. Our biggest perfect square was 9. So we broke 63 into the square root of 9 times the square root of 7. And the square root of 9 was 3, and square root of 7 stays that way. Now we need to go ahead and look at what's going on with the square root of x to the 9th. Now remember that x to the 9th is really x times x times x times x times x. 9 x's here. 1, 2, 3, 4, 5, 6, 7, 8, 9 x's is really what's happening. And so when we talk about x times x, that being x squared, I have pairs of x's. 1, 2, 3, 4, and then this lonely one over here is going to have to stay under the radical. So that means I have 1, 2, 3, 4 groups. So I'm going to have x to the 4th. So that will go here, and I'll say times x to the 4th. Times x to the 4th. That comes out of the radical. And then times the square root of x. That's where this lonely one stayed underneath the radical. Now to simplify this, I need to put 3. Let's switch colors. I'm going to go ahead and put 3 x to the 4th on the outside. These are my outside pieces. And then the square root of 7 and x stays underneath there. So make sure you keep the 7 and the x under the radical sign. A shortcut way to look at this is to say, if this is odd, I'm going to have 1 left over inside. If it's even, it's going to be half as many. Let's go ahead and work through the try-its together. Here we have the square root of 25 x cubed. Well, the square root of 25 is 5, and we have an odd exponent, so we know that we're going to have 1 left inside. So we're going to break down that x cubed to be the square root of x squared times the square root of x. I can take the square root of x squared and get x, and then this one needs to stay inside. This 5 on the outside is just being multiplied times the whole thing, so we're going to put 5 times, and we're going to break this down to the square root of 4 times the square root of x. Let's make it to the even 16th, and then times x. So we've broken this piece right here down into the square root of 4, the square root of x to the 16th, and the square root of x. Because the square root of x to the 16th times the square root of x would be x to the 17th. We can take the perfect square of 4, which is 2. The square root of x to the 16th is x to the 8th. And then we cannot simplify any further on the square root of x. Multiplying 5 times 2 is 10, x to the 8th square root x. Let's go ahead and work through example 4 in the same video. In order to do this, let's first combine these two expressions into one. So in order to do that, I'm going to multiply the number parts on the outside. So 2 times 3 is 6. And then multiplying the insides, I have 5 times 15, which is 75. And then x times x cubed is x to the 4th. Now we can rewrite this into 6 times the square root of 75 times the square root of x to the 4th. We can see that 75 actually is divisible by 25, and that's a perfect square. So I'm going to go ahead and I'm going to break that down into the square root of 25 times the square root of 3. And we still have x to the 4th, and we still have 6. I'm going to rewrite this one x to the 4th because it was looking like x4 instead of x to the 4th. Okay, here I can take the square root of 25, which is 5. I cannot simplify any further the square root of 3, but I can simplify the square root of x to the 4th and get x squared. So putting that all together, 6 times 5 is 30, and x squared goes on the outside, and then we have the square root of 3 left over on the inside.